Moving on to question 12. For this one, I want you to calculate the net force for all of these. So multiply mass and acceleration. 60 times 1.8 is 108. 58 times 1.7, 98.6. And then 62 times 1.6 is 99.2. Based on the table, which one of these will have the largest net force? It's going to be Neil. And it's Neil because although he does not have the most mass, he does have the most acceleration. That multiplied together will give you the highest net force. So Neil, because net force needs both mass and acceleration. So although Neil is not the highest mass, he does have the highest acceleration. He has the most acceleration. Done. And then which way would a student who is running on the sidewalk and hits the ice continue moving? So if this person is going this way, the person is going to continue with the same path in the same direction because of Newton's first law. So Newton's first law says the student will continue in the same path with the same velocity as they were running in. They were when they slipped. And then when viewing a force and acceleration graph, what is the force and what does the slope represent? So here we are. If this is force and this is acceleration, this number is going to be mass. So if the slope is really high, this is telling you that it required lots of force for little acceleration. So this is going to be a larger mass. And then if you have something that's not as steep, so if you have a force and acceleration graph that's not as steep, then this is going to be lower mass or less mass. Okay, so then that way we can rank these now. So if we're doing a ranking task and you have 4 students running to the class, rank the graphs of who has most mass to the least amount of mass. So higher mass is going to be the steeper of the slopes. That's going to make it A. A is steeper. Remember, steep is like if you were to slide on it, which one would you go faster on? So it's A followed by D, followed by C, and then finally B. All right. The next set of questions here, these are the ones that my students struggle with the most. And the reason why is because it looks like they only give you one thing of information. And you're like, well, what am I supposed to do with this? I don't have enough information. But you do. Okay, so you have to remember that G of Earth is 9.8 meters per second squared. If you remember this, then you can do these problems. So weight is Fg. Fg is 630 newtons. It's a newton, so it's a force. And I'm looking for m, which is the mass. How do I solve this? Fg equals mg. Fg is 630, m is x, and 9.8 is my acceleration. So how do I solve this? Divide 9.8 to both sides. 630 divided by 9.8 is 64.3 kilograms. And here we have a dog that has a mass of 20 kilograms. And then you're like, oh, well, I don't have enough information. Wrong. You have 9.8. And you're going to find Fg. So in this case, this is the one where you don't have to do any algebra. Please do not try to solve for anything. Do not rearrange. X equals 20 times 9.8. Just multiply the two numbers. 20 times 9.8 gives you good old 196 newtons for this dog. Right? And then what will never change with location? Mass, because it's about matter. And we said you are made out of matter, so you matter. And then what changes with the location? Weight. And I wouldn't even say location, but remember we talked about the elevator. So if the elevator is going down, you weigh less on a scale because the floor is leaving you literally. And if the elevator is moving up, you're going to weigh more because the scale is pushing up on your body. So Ms. B sends you to the space station to gather data for physics. What happens to your mass and weight? Well, in this case, you are weightless. Remember from the video, this is because you are always falling. But your mass is unaffected. I think I forgot Anna on this problem. Alright, this puts me at 8 minutes for this video. We're going to create a new video for the last of the problems, and hopefully that would be it.